Hello everyone, I'm Tobiloba. I'm a software engineer and developer relations engineer at Flick. I've been building software applications for about 3 years now, and in that 3 years, I'm gotten the privilege to work with across so many industries, from entertainment to dev tooling. Yeah, so excited to be here today to talk to you about this really exciting topic, maximizing AI efficiency with Upstash Vector. I'm sure you guys have heard like AI a lot today. Let everybody say AI, AI. Say AI. So this is like an interactive session. I'm going to be showcasing more doing than and less talking. So no cho. So yeah, moving on. Preface. So you guys are probably like, I don't know. Most people have used like generative AI, right? Let's say ChatGPT, Claude, or Bard when it was Bard. Now it's Gemini. So you probably use like AI a lot, and you've seen how generative AI works, right? You know the idea. You just input a prompt, and then you get a response, right? And then you don't actually care how that response comes back, but you know when you put it in, it comes back instantly with the response. So there are so many optimizations in that regard that helps that happen, and one of them is actually using semantic caching. Yeah, let me just move on. So as AI applications grow, both cost and latency increases, and this often leads to like performance issues and unaffordable infra. So as your AI application grow, you actually cannot afford to ensure that somebody is just wasting your like processing power to maybe find out what the capital of France is, or maybe what trenches means, or something like that. So you need to actually manage like your AI and stuff. Yeah, cost and stuff, because I mean, infra is very expensive right now. It's not, yeah, it's not bread. Solution overview. So, yeah, so I'm going straight into the solution. So, like I said, less talking, more doing. Yep. So, overview. Essentially, I'll be using Upstash Vector. So, a vector is like a fuzzy, it's like a serverless DB sort of thing that you use with AI applications for like caching and many other operations. And I'm using Upstash. So, Upstash is Upstash is a serverless Redis provider, and they have something called Vector, really cool stuff that I'll showcase to you. And I'm using something called Semantic caching. It actually has a package that works for that, and I'll be using my A server. So I'll set up an Elysia.js server. I don't know if you know. Does anybody know Elysia.js here? See, I've been using a server for actually maintaining that entire application, and I'll show you a Next.js application as well. So there's like this Next.js application I have set up that I'll show you. With that. So prerequisites, an Upstash vector database, basic understanding of LLMs and semantic caching. Who here knows the full meaning of LLM? LLM. Eh? It's not like, I'm hearing like, it's not like you, it doesn't lie, there's large language. Eh? Okay. So, familiarity with Elysia.js and Bond, that's basically like if you have experience using Express, it's basically the same thing. So I don't know if you know of the Bond hype. If you write JavaScript here, you probably heard of the hype. So, so yeah, I'm using Elysia.js for this. Key concepts. I just like put this page here to explain some things. So LLM, large language models like GPT-3, BERT, T5. Upstash Vector, a vector DB optimized for AI workloads. Semantic caching, it caches results based on their meaning. That is, if you ask, say for example, where is Nigeria? You get a response back, it caches that. Then later on you ask Nigeria where? Where is Nigeria and Nigeria where? To a normal human being, you understand that those two questions are similar, right? But how does your AI know that, right? So, yeah, this semantic caching is that process of actually making, how would I put it, that response to be sort of semantically cached. So, caching based on meaning of question. Does that make sense? You get like, that's literally the entire point of this talk. You can leave now if you want to go, but let me just show you if you're going to stay like this. So, Elysia.js, web framework for backend servers, use the bond. So, essentially, this is what the process is like I've been talking about. So, you are a user, you use your AI or whatever generative AI that you use from somewhere, and then this is your AI here. So, semantic cache just stands in between the user and the AI. So look at this response now. So you ask capital of USA. It goes straight. It misses because it doesn't find anything similar to capital of USA. It hasn't gotten that kind of question before. So it goes to your AI, gets a response, it sets it inside your semantic cache, and then it gives you the response. The user sees Washington DC. You actually don't care what happens. You just want to see Washington DC, right? So now you come again to ask US capital. It goes, checks your semantic cache first. It finds a hit because US capital and capital of USA are very similar questions, right? So from here, it just takes it back and gives you the response. That's the entire flow of what I'll be showcasing to you now in code. Yeah, so as Big Kala says, no church or church. So I want to show you workings now and actually show you how this works. Is everybody down with me? So all this one I've been doing since was like church or church. Let me actually show you how it works. Yeah, I like Odumodu sometimes. So code walkthrough, let's do it together. So I'm just going to go, where's my cursor? I think I see it. Oh, all right, it's here. This is tiny. I need to expand this. Can everybody see the screen? Is it like large enough for you to see? Okay, so yeah, let me just walk you through this code. So I'm not going to actually like stress you out with too many things. So a few things you need to know about this code. I'm using a package called Semantic Cache from Upstash. I'm using the Upstash vector package. That is what gives me access to that thing I showed you that was in between the user and the AI. Did you guys see that part? That diagram? You didn't see the diagram? It was like right here. Let me show you. This diagram. So it's, whoa, what's going on? So you were asking, right? Yeah, so this is what I was referring to. So this is like that semantic cache. Yeah, sorry, big color again. So let me actually go back here. Yeah, so now I was showing you my package.json. So Upstash vector, which is that thing that I just showed you now. That sort of like gives you the context for that index kind of DB. And then Alicia, the server that I'll be running. Can you guys see the screen from over there? Are you comfortable? All right, awesome. So now in this code, essentially, I have like this file that I'll be running with Bun. So Bun is like easy with TypeScript. I think Node.js has too now, but like I can just run the script. Yeah, so essentially you create your vector DB. You set up your semantic cache. You can see that it's coming from this package. And then I have this function that essentially sets the question and then sets the response. Can you see this part? Very key part of the code. So I give it a question, it sets that question, and I give it a response, and it sets that response. And then essentially, I ask this question, largest city in USA by population, and I'm asking a similar question here, but you notice that these two questions are not the same, right? Can everybody see that? There's like one word missing, or like, actually, yeah, like there's like a rearrangement of the entire sentence itself, right? Everybody can see that. So, yeah, different question. One is largest city in USA by population, and now it's going to try to ask this question, the second one. And then I'm just using performance.now in JavaScript to like check the time between those two questions, and then I essentially give you the response. So real quick, let me actually show you something. Do I leave this? Escape. Yeah, so let me just show you my Upstash. So I created an Upstash console to actually undo this entire operation. I actually went sort of like a vector DB. So let me expand this. Yep, so I can actually go back here and like come to Redis. So Upstash has like this dashboard for you, like your sort of portal for yourself that you can create easily, like with your maybe Google account or GitHub account or something. So I already had one created. We can actually I can show you the process of creating a vector now. So you actually just like create an index for yourself, impute whatever name you want to give it, choose the default model because you want the closest one to you. Apparently this is the closest one they have to us, to Nigeria. So embedding model, so they're like different models here that you can work with because these models are essentially going to take that question coming from you and be able to interpret it whenever you ask a similar question, essentially. Because when you ask a question of, okay, let's say you've said, what is my name? And you said Toby. My name is a similar question to what is my name, right? So you expect Toby back. So this model can interpret that. So they have some smaller models here, and that's what I'll be using because the smaller models are more faster. Precision could be lower, but if you want more precision, choose a larger model. But I'm optimizing for speed here. And then you have dimensions. So the higher the dimension, the more the precision. But because I'm in a free plan here, I can't actually choose like anything too big. Is everybody following? You guys look confused. You are following. Are you sure though? Or is it boring now? Yeah? Okay. Yes, let me know it's boring. Maybe we can play songs. But I have a very controversial taste in music. So it may not be, I don't know. Yeah, like shady vibes and stuff. So, so moving on. So I created this like index for myself called semantic caching. So we can actually like check this out. I already set everything up here, but I just showed you that to like see how that is. I'm in Vector currently. Now we'll come to this data browser because this is where we'd actually verify whatever questions have been asked and that have been set in our semantic cache. So I think this is empty. Drex's network is still good. Yeah, it's empty. So we come back here, and I'll run this code. So I had this one running, just to test that, so that I'll not come and drop my SDs. So let me just npm run dev. So when I run dev now, that's double P. So when I run dev now, I actually like returned this object here from down there. So you can actually see I'll respond with this object that contains cache response, the response that comes back from that question, and the time taken for that question. Because this is bare bones like semantic cache, you may notice some fluctuations in the time, but generally the time would actually be reduced. So let's do that. It's like a while loop, so it's just keep running. Hope my computer doesn't crash too. But let me run it. But everybody brace, like in case anything happens. So yeah, look at first time 372.9 milliseconds. Just like there's a fluctuation, keeps dropping. Sometimes you see like 200 from the initial like time. So it keeps making asking that same question because I've coded into in my code here. You guys saw that, right? Everybody saw that, right? The question of New York. So I had coded that and I kept asking the same question. So I actually like logged the time that it used to respond for that same question. But there'll be fluctuations here because obviously I'm like using like bare bones semantic cache. I'm not actually interacting with an AI model to give me that response back. So this is just me interacting with that DB directly. So if I go back to my DB and I refresh this, that question of what is New York is already here with the response, largest city by population, and whatever. Can everybody see this? Am I blocking the screen? So I've already cached this question here. So even if you ask any similar question that involves anything with population or biggest city by people or something semantically similar. Wait, am I using that's tautology? Sorry. So something similar actually to that question. So it just responds with New York. Is everybody following actually? Okay, now, so this may be like server stuff. So for those of you that want to see UI, I actually did a Next.js implementation of this same thing. So I went to pay $10 to OpenAI yesterday because they said they will not give me anything if I don't pay money. So I went to beg my helpers and I told them that I want to come and present today. So you guys should like enjoy this and let us finish all the credits together. So because I'm not giving OpenAI any hard end begged for money. So yeah, I have this like, let me actually show you the code. So there's this like, I already have this Next.js application set up here. So this one, we can actually ask any questions. So I'll pick like, or you can just volunteer to ask any question. So essentially, I don't know if you use Next.js here, but if you have a front-end developer that uses Next.js, you can set up your own simple APIs for like post or GET request within your Next.js application. Do you know that? Like your own API. So yeah, that's essentially what I'm doing here. So this is the code that handles that same packages that I showed you before. But I'm using Vercel's AI SDK so that when the data comes back, it generates the data with the UI. Because the data is actually going to be streamed back to my application. So I can't essentially like say, okay, give me this response directly. But I can actually stream it and show that the way ChatGPT does it, where you see that. But I want the UI to be generated directly with the data so that it just render at once. Does that make sense? All right, so just for better experience. So semantic cache, essentially like, so this first part of the code is just like an early return. So it checks if the data already exists and it responds with it. And then if it doesn't, I actually call the generate text from Vercel, and I like use and I call OpenAI. I'm using the GPT-4.0 model. I I think that's the base one in like your current GPT, I mean chat GPT rather, right? Am I mistaken? Alright, so did I delete something? Oh sorry, my bad. So so a prompt with another query that comes that I actually want to ask, which is just your question. And then I set that question and respond with that. So I have this application running, and essentially, I'll push this code to GitHub. So I think it's already on GitHub. But for you to run this application locally, you just need to like get some data. So you get your token from Upstash, you get your URL from Upstash. They provide it directly here on the UI. If you go back here, I think if I click on this again, you see like the URL for, yeah, so you see this URL, this something slot. Let me just adjust this. So, okay, I think I can minimize this. And I can make it full screen again. I don't need a shortcut to that, so forgive me. So yes, so you can see like this URL, this something slot here, and then my token as well. It's hidden, but I can actually get it from within the project. And then you need your OpenAI key. That's if you are very rich enough to have an OpenAI key. So yeah, and then the application would run. But at the moment, those of us that are still hustling, so I went to beg for this key actually. They said they will not give me that. Yeah, sorry. So let me run this. This application is running on port 3000, localhost 3000. So does anybody want to ask any question? God of demos, let this work. Have you God of Elijah? Any God? Eh? Let's see what to say. I hope he doesn't call the Toby from Shopify though, because they don't know me. Who's Toby's favorites? So this is calling ChatGPT. I don't know if ChatGPT will know American favorites. I'm British, right? Artists. So let's see. So it's making the request, calling the model. Everything looks good. So I'm sorry, but I don't have. Wow. Damn. I need to also. That's just an indication. So it says, I'm sorry, but I don't have information on who Toby's favorite artist is. Toby is a common name, and yeah. So let's just ask the same question again. So look at the time. This took like about. Is this 4 seconds, right? Like, I'm not very good at math. Sorry. So let's ask the same question again. Now look at the exact same question. Look at the time that it took. Could you see that? Did you see that time drop in questions? I mean, that time drop in the same question. Now let's check our DB. Let's go and check data browser to actually see that maybe the data was added to the DB. So if I refresh this, do you see that there? Everybody clap for me now. You guys are. Thank you. Thank you. Thank you. I appreciate it. I have it small, just small. Who wants to ask a question? Huh? Oh, I should change this. Okay. So maybe favorite artist of Toby. Okay. Artists of Toby. Semantic cache, way lesser time than the initial request still, but it still gave us the response, right? Oh, no, it doesn't add it just stays the same way. No, it doesn't. So if we refresh that, so these two questions will stay the same. Yeah. Right? Somebody ask questions now, like this is your chance. Let's finish these credits. Eh? Okay. So, who is Shay Vibes? I'm only hearing who is Shay Vibes. Who is Shay Vibes? So he's responding, oh, nice. No Shay Vibes. Okay, so now let's ask a variation of the same question. Does anybody want to suggest what I should type? Eh? Do you know Shay Vibes? What can Shay Vibe? Yeah, now. Do you know? One sec, I'll ask that one too. Let's see what it say. Do you know Shay Vibes? So Shay Vibes took about 4 seconds still to respond. And do you know Shay Vibes took way lesser time? Semantic caching, guys, everybody. So, thank you very much. So, yeah, I think that's like the demo. I probably still have enough credits to go and waste at home. But, yeah, so essentially that was semantic caching in action. And I actually um, gave you like a real user application of what it is and how it works. So, Upstash is really cool. So, for like that kind of operation, I don't work there. I just found out I was cool. So how do I take this back to slideshow? Sorry. So continuing that, some other ways to save costs: use smaller models so that they are faster and like maybe use less tokens and stuff like that. But that depends on your use case. Q&A after. So optimize model usage. Whatever models you are using, if you know the AI engineer and they are not a scam, work with them to optimize it. Fine tuning. So feed it more data so that whenever it gets a question, it actually responds to the question and other stuff. Bullet 4. A little longer example. Wow, somebody touched my slides. I actually did not write that. My bad. So on-demand scaling. So there is actually another way. So as your like AI model usage increases, you actually should scale. So that actually includes like physical infrastructure, which is very expensive right now because if you can actually afford to scale your own AI, you are like, maybe you are related to Dangote or like maybe you are a trust fund kid. I know there are some of them here. You guys are looking peng. So moving on. So shout out to GUI and the Akiri Labs. So I work with this bunch of amazing people. They're like MetaMask engineers. So we have like this very small club called Akiri Labs where we like do AI engineering and we just like play around with like AI stuff. Yeah, we don't write AI, we do AI engineering. It's like a field where you are like a software engineer that uses AI models or stuff to like build stuff. So yeah, shout out to him. Like, yeah, this is his picture. The guy don't make him, but it's just I don't know why it looks. Moving on. So, links and handles. Thank you, actually. Thank you very much. You guys are awesome. Links, check out Akiri Labs. Check me out on Twitter, Toby Solutions. LinkedIn, Tobiloba, and GitHub, Toby Solutions. So the repo link is on the slides. And thank you all for attending this and for being a good audience. This is Sherry Vibes.